Okay, let's also try a demo module of the heavy vehicles from the heavy vehicles class of content. Yeah, so I believe this is going to be about the brake system.
Introduction. As soon as the driver presses the brake pedal, an electrical signal is sent from the control unit to the axle modulator. The axle modulator receives the signal and builds up pressure in the diaphragm brake cylinders. The control unit needs to know how hard the driver wants to brake. The brake signal transmitter passes this information on to the control unit. Click on the brake signal transmitter.
Do you see what I pressed on with the
Correct.
mouse? This is the
This is the
transmitter.
brake signal transmitter.
You can look at the diagram if you want. It's available. The EBS, electronic brake system, the parking brake, and the service brake. Let's collapse it and continue the class.
What is correct about braking with the brake pedal? The further you press the brake pedal, the higher the air pressure becomes in the diaphragm brake cylinder. The higher the air pressure in the diaphragm brake cylinder, the harder the brake brakes. If you press the brake pedal all the way down, only a response pressure is built up.
Let's try true for the first statement, true for the second one, and false for the third one.
Correct. We call this dosing the braking force. Slowly drag the brake pedal further and further down. What can you do with the brake pedal? Brake gently. Dosed braking, everything between gentle and hard braking. Brake hard.
Okay, I use the mouse. You can see the response on the dial here. Yeah, so I believe all these answers are correct. All these statements are true.
Correct. The driver determines the braking force with the brake signal transmitter. The deeper you press it, the higher the pressure.
So move to the next page.
Function. The brake signal transmitter converts the desired brake value, deceleration, from the driver into an electrical signal for the control unit. The brake signal transmitter is the successor to the old foot brake valve. The brake signal transmitter still contains a foot brake valve, but it is only used in the event of the electronics not working, fault. How can you indicate how hard you want to brake? With the brake signal transmitter.
True.
With the accelerator pedal.
No.
Correct. The control unit can determine from this signal how hard the driver wants to brake. Which statement is true? The brake signal transmitter receives a signal from the control unit. The brake signal transmitter measures how deeply the driver presses the brake pedal and sends this information to the control unit.
I believe the second answer is correct.
Correct. The control unit can determine from this signal how hard the driver wants to brake.
Move to the next question.
What is the function of the brake signal transmitter if the EBS system is fault-free? Converts the desired brake value from the driver into an electrical signal. Builds up the correct air pressure in the diaphragm brake cylinder.
I believe the first answer is correct.
Correct. This signal goes to the control unit.
Go to the next question.
What is the function of the brake signal transmitter when the EBS system is in fault mode? Calculates the correct pressure for the diaphragm brake cylinder. In this case, the pneumatic part, foot brake valve, of the brake signal transmitter doses the air pressure for the diaphragm brake cylinders.
I believe the second statement is correct.
Correct. The foot brake valve is attached to the brake signal transmitter.
Okay, we will move to the next page of the class.
Location. The brake signal transmitter is located under the foot brake pedal in the truck's cabin. The brake signal transmitter is electrically connected to the EBS control unit. Pneumatically, the part is located between the storage reservoirs and the front axle modulator redundancy valve. Click on the brake signal transmitter.
So now this is an instruction. Brake signal transmitter must be here.
That's right. Click on the brake signal transmitter in the diagram.
So it's over here. So we move to the
Correct.
next page.
Construction. The pneumatic foot brake valve has been enhanced with a brake signal transmitter. The brake signal transmitter is the electrical part that is located between the brake pedal and the foot brake valve. The terms can be confusing at times. The complete combination is often referred to as a braking power transmitter once it has electrical connections. Click on the brake pedal to make it transparent.
So I'm going to click on the pedal. And you can see it became transparent.
Correct. The brake pedal is transparent now.
Next question or instruction.
Click on the pneumatic section, foot brake valve, to make it transparent.
I believe it is this part.
Good. Now the foot brake valve is transparent.
Move to the next question.
What is the name of the part that is now visible? Brake signal transmitter. EBS control unit. Foot brake valve. Spring. Brake pedal.
I believe that is a brake signal transmitter.
Correct.
So now we move to the next page of the module.
Components. The brake signal transmitter consists of an electronic part, EBS, and a pneumatic part. The important parts are explained below. Electronic part, EBS. Zero contact. This micro switch switches with a very small pedal stroke. The signal goes to the control unit. Pedal stroke sensor. This non-contact sensor determines how far the brake pedal is pressed based on a changing magnetic field. The signal goes to the control unit. Connector. The electricity cables are connected to this connector. Pneumatic part. Spring transmits pedal stroke. This spring transfers force from the brake pedal to piston circuit 1. Piston circuit 1. When the brake pedal is pressed, this piston is operated mechanically. The piston lets dosed airflow from the storage reservoir to the rear brakes. Piston circuit 2. This piston is pneumatically operated when the brake pedal is pressed. The piston allows dosed air from the storage reservoir to the front brakes. Click on the housing to view it from the inside.
Okay, that's an instruction.
Good. Now you see the inside of the brake signal transmitter, the electrical part.
So we go to the next question or instruction.
Set the switch to EBS inoperative. What can you say about the parts you see? These parts are needed in order to brake with EBS. These parts are necessary to be able to brake without EBS.
So EBS operative, now switch it to inoperative. So the parts I see are those that are needed to brake without EBS.
Correct. These parts are very important if the electronics are faulty. Now set the switch to EBS in operation. What can you say about the parts you see now? These parts measure the braking signal. These parts are used by the EBS system. These parts put pressure on the diaphragm brake cylinder. These parts send signals to the control unit.
Yes, so everything that is highlighted is electrical now. There is no hydraulic components visible. They have been made transparent. So yeah, first statement I believe is correct. So is the second one. I believe the third one is incorrect. And I believe the fourth one is also correct. Let's check.
That's right.
So we'll move to the next instruction or question.
Press the brake pedal to operate the brake signal transmitter. Which statements about the zero contact are correct? The zero contact is switched on immediately as soon as the driver presses the brake pedal. The zero contact measures how far the brake pedal is depressed. The zero contact is a micro switch.
Okay, now this is a zero contact where my cursor is, and this is a pedal stroke sensor. So if I were, this is the brake pedal, so if I'm to press the brake pedal, I'm going to do that now by left clicking on the brake pedal. So I'm going to answer as follows. That is it true? No. The third one is also true. Let's check.
Correct. The zero contact is already enabled with the smallest pedal stroke.
So let's go to the next question.
Press the brake pedal again to operate the brake signal transmitter. Which statements about the pedal stroke sensor are correct? The pedal stroke sensor is a non-contact sensor. The pedal stroke sensor is located in the brake signal transmitter. The pedal stroke sensor uses a changing magnetic field to determine how far the brake pedal is pressed. The pedal stroke sensor is a position sensor. The pedal stroke sensor is a micro switch.
Okay, press the brake pedal again. You can see here in the expanded view what's happening with the micro switch and the brake pedal stroke sensor. So I'm going to answer statement 1, yes, true. Statement 2, yes, correct. Statement 3 is also correct. 4 is also correct, but statement 5 is false. So let's check.
Okay.
Let's move to the next page. Next question.
Click on the parts of the brake signal transmitter. Zero contact. Connector. Pedal stroke sensor.
Because I'm running out of time for this clip. So I've moved on to the next page.
Operation. The construction of the brake signal transmitter is the same as that of the foot brake valve, only a piece of electronics has been added. As soon as the driver touches the brake pedal, a very small pedal stroke, the zero contact sends a signal to the EBS control unit. The control unit then controls the front and rear axle modulator to build up a response pressure. When the driver continues to press the pedal, the built-in pedal stroke sensor measures how deep this goes. It is a measure of how hard the driver wants to brake. The pedal stroke sensor sends a PWM signal to the control unit. Based on the PWM signal, the control unit determines how much pressure must be sent to the diaphragm brake cylinder to achieve the desired braking value. PWM stands for pulse width modulation. It is a signal that changes duty cycle. The electronics in the brake signal transmitter are often redundant. This is done for safety and fault detection. First, we will look at how building up the response pressure works. Drag the brake pedal down a bit to make a very small pedal stroke.
Okay, following instructions. Let's check.
Good. The zero contact gives a signal to the EBS control unit that the response pressure, 0.4 bar, must be built up. Drag the brake pedal down a bit again and take a good look at what happens. Which statement, S, is /R correct? The signal changes, color in dots. A response pressure is built up in the diaphragm brake cylinder. The zero contact is pressed. In reality, the pressure in the diaphragm brake cylinder doesn't allow the brakes to brake just yet.
So I believe this is true. This is true because this moved, this dial moved. Yes, this is true. I believe this is also true. Let's check.
Correct. At the response pressure, the brakes are ready to brake quickly.
Next question.
The signal from the brake signal transmitter, for the response pressure, is actually an electrical signal of 0 to 12 volts. Drag the brake pedal again to repeat the small pedal stroke. What happens? The brake signal transmitter sends a signal to the EBS control unit that the response pressure must be built up. The signal for the response pressure jumps from 0 to 12 volts. A response pressure is built up in the diaphragm brake cylinder.
So I believe all three statements are correct.
Correct.
Next question.
Which part in the brake signal transmitter supplies this electrical signal, response pressure, to the control unit? Foot brake valve. Pedal stroke sensor. Zero contact.
Just to be sure, let's do that again. See, every time I tap on the brakes using the mouse, we see 12 volts. So it must be the zero contact. Check.
Correct. This signal tells the EBS control unit that the response pressure must be built up.
So let's go to the next question.
Now press the brake pedal further by dragging the brake pedal. Which statements are correct? The colored dots change depending on how deep you press the pedal. The brake signal transmitter sends colored dots, the brake value, to the control unit. The color of the dots to the control unit indicate the brake value.
Okay, let's do that. See the harder I press on the brake pedal using the mouse, the deeper the colors change from gray through yellow, orange to red. So this statement, first one is correct. Second one is also correct. Third one is also correct.
Okay.
Next question or instruction. Yes, so I'm going to move the brake pedal again and check here in the view to check the, this is an oscilloscope view of the signal. You can see that the pulse width modulated signal is changing. The PWM signal is changing. Yeah, so we check, I've done that, so it will accept that.
Good. Now the PWM signal is visible. Which statement is true? The duty cycle of the PWM signal changes when you press the brake pedal. The voltage of the signal changes when you move the pedal.
So it is the first statement that's correct.
Correct. This tells the EBS control unit what the position of the brake pedal is.
Of course, there is a class for about these types of signal from sensors. So when you get access to the entire course, things like PWM signals will become normal to you. You understand them. You understand what they mean. But for purposes of keeping this video short, I'm not going to elaborate that. I'll just answer the questions.
Which part in the brake signal transmitter provides the PWM signal to the control unit? Pedal stroke sensor. Zero contact. Foot brake valve.
So we know the correct answer is this one, the first one, pedal stroke sensor, but I'm just going to give the second answer for now just to check, just to show you what will happen if you give a wrong answer.
Incorrect. This is a 0 to 12 volt signal that is used for the response pressure.
Okay, so we shall answer give the correct answer and then move on.
Correct. The signal indicates a braking value.
In reality, the system, the learning system will score you accordingly. Yeah.
Which statement, S, is /R correct? The zero contact tells the control unit whether a response pressure must be built up. The PWM signal tells the control unit what the desired brake value is.
So both statements are correct, so I'll answer accordingly and check the result.
Correct.
So move on to the last page of this module.
Function test. You can often see on a diagnostic device which values the brake signal transmitter transmits to the EBS control unit. Another possibility is to measure directly on the brake signal transmitter with an oscilloscope. To increase the reliability and safety of the system, the zero contact and the pedal stroke sensor are duplicated. Consult the manufacturer's manual for details.
So this is the electrical diagram on display here.
Click on one of the two pedal stroke sensors in the electrical diagram.
The two stroke sensors are actually these two, 6 and 4, E6 and E3. So click on that. What is it? Oh, pedal sensor. There are two.
Incorrect. This is a zero contact.
Yeah, sorry. This is pedal stroke sensor 1 and pedal stroke sensor 2.
Correct. This is a pedal stroke sensor.
Yeah, you see how one needs to be careful with the wording of the question. We'll move on to the next question. Yeah, the zero contact is this one.
Good. The zero contact is also called a micro switch.
Go to the next question.
View the signal from the left pedal stroke sensor. To do this, connect the oscilloscope and move the brake pedal up and down. What is correct? I don't know how to measure. The PWM signal changes from 10% duty cycle to 90% duty cycle as soon as the brake pedal is pressed. The PWM signal changes from 90% duty cycle to 10% duty cycle as soon as the brake pedal is depressed.
Okay, let's carry out the instruction. Left pedal stroke sensor is what they need us to measure. So the left pedal stroke sensor, it's the signal is on pin 7 of the sensor. So if we take the diagram away, this is pin with pin 7. Oh, we're on the ECU, not the sensor. Yeah, this socket is on the ECU, not the sensor. So bring back the diagram. So we need, it pins on E5. So take the diagram back. We need to put the oscilloscope on pin E5. Yeah, and we also need to put the black common pin on the ground connection, which is according to this diagram, these are all signals E5, E2, E6, E3. Now, E4 must be a power connection to all the sensors, and E1 must be the ground. So I'm going to check that. Put this on E1. Why isn't it playing ball? Let's check the diagram again to be sure. It is also possible that this pin E4 could be the ground because it's common to all the sensors. Let's try that. That's not working. Does it want me to connect the common cable first? Why isn't that working? Okay, there is a terminal here for ground. Yeah, so it wants us to use the battery ground rather than the sensor ground, and we take this back to E1. Let me check the diagram again. E5, signal is on E5. I will move this to E5. Yeah, we can see the signal is there, and the signal is, that looks like 90% duty cycle to me, and when I apply the brake, it does shift from 10% to what looks like 90. That looks like 90%. Yeah, so we have measured. So number one, we shall skip it. The PWM signal changes from 10% duty cycle. No, I think it starts from 90 to 10. Yeah. So after following instructions, we've done that. They are, of
Correct.
course,
From the duty cycle percentage, the EBS control unit, ECU, determines the position of the brake pedal.
yes. So now there are other classes that explain how to read these diagrams, like I have, and also how to use equipment like the oscilloscope to answer these questions. Those will be in the real class. They are not included in this demo class, but now you get a good idea of how interactive this learning system is. So we move to the next question.
Now compare both signals from the pedal stroke sensors with each other. Connect the red probe to E5. Connect the blue probe to E2.
Okay.
While measuring, press the brake pedal again. What is correct? I don't know how to measure. The PWM signals are opposite each other. When one signal is 10%, the other signal is 90% and vice versa. The signals don't change.
Yeah, so from what you can see, they are mirror images. The signals are mirror images of each other. That's the redundancy that is being discussed up in the descriptive content up there. So this must be the answer.
Correct. This makes the EBS control unit more capable of detecting errors.
Okay, next question.
Now check the operation of the zero contact. Use both channels of the oscilloscope again, then drag the brake pedal up and down. What is your
Right.
conclusion? The zero
Okay.
contact is okay. When pressing the pedal, E6 goes to 0 volt and E3 to 12 volts. The zero contact is broken. I don't know how to measure.
Yeah, so because we are at the EB socket, so we are going to put the red probe on E6 and the blue one on E3. And bring the oscilloscope out. Yeah, the blue is at 12 volts, red is at 0. So when we take the foot off, they change. The blue goes to 0, red goes to 12. You see the change on the oscilloscope. If you did it quickly enough, you could see those changes. You can actually no, on this oscilloscope I can't play with the time scale, so we shall leave it at that. But the correct answer is the first one.
Correct. The zero contact switches when the brake pedal is pressed. There is voltage between E6 and E3.
Okay, let's move on to the next question.
Which statement about the zero contact is correct? The signals are opposing. This makes the system safer and fault detection better. The signals are the same. This makes the system more prone to errors.
Yeah, it must be the first answer. Correct? We check.
Correct. In the case of the signals being the same, the EBS control unit knows something is wrong.
Yeah, so that was the final question, I believe. We've reached the end of this module. Thank you very
You
much
have
for
reached the end
attending.
of this module.
Yeah, thank you very much for attending. This was a good example of a module within the heavy vehicle class.